Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today we're going to bring a Belmont radio receiver back to life from 1947. So let's get started. Here's the radio that we're going to electrically restore today, and we're going to make this thing perform the way it did back in 1947, or maybe even just a little bit better, because we're using modern components. The paint itself is in very nice condition. There are a few nicks and scratches, but that's really nothing that some color-matched paint wouldn't fix. It would be a shame to repaint this whole case just for those nicks and scratches because everything is all original. It even has the original Belmont sticker on the front, so I wouldn't want to interrupt that. You can see down here it could use a little bit of touch-up paint and things like that. A little spot right here and so on. Everything seems to work. So the tuning works. That means the dial string is good. And the presets seem to work. Now they're all kind of set for one area. There's a bit of a trick to set this. It's really easy. I'll show you that throughout the video. That still clicks, so the on-off switch is clicking, whether it electrically works. We don't know at this point, but we'll find that out. So you can see the case is very nice. The backside isn't too bad, a little bit rough. You can see the back has been damaged a bit where it's been removed. Obviously this is a high mileage piece. This has been on and off many times, most likely to change tubes throughout the life of this radio receiver. And when these were original, they had a little press pin that would press into the case, and it had little tabs that would tension into here. And the reason that they did that back then is so people wouldn't drive screws through this and crack the case. And as you can see, it now has screws. So because you have to pry those little pins out is usually why the damage happens on the backside here. So, but still, it's in very nice condition for, 1947, right? So what I'm going to do next is I'm going to remove the screws off the bottom here. So I got to remove these 4 screws here and just remove the screws on the back. Take the screw out on the tuning knob here and let's move this out of the way. Pull this off and the whole inside should come out, and we'll take a look at what's on the inside and what we need to do to bring this thing back to life. Here we are inside the radio receiver, and the first thing that I want to do is remove the back so that I don't cause any more damage to it. And there's just some little clips here that you can press a tab and take the wires out. And they've marked the color of the wires on the back, whether that's correct. I'll have to look at the schematic and find that out in just a little while. So I can get this thing out of the way because this is pretty fragile. Need to replace this capacitor here as well. You'll notice that I've put the tuning knob back on again just because without this on, the whole mechanism is loose. So the actual knob itself holds this pulley tight and everything. So that's the reason that I've put this back on. I haven't put the front volume control and on and off switch knob on. As you can see, the speaker is in very good condition. Just very, I guess you could say one very slight crack here. That's it. It's very nice condition for its age. It looks like somebody's even tried to repair that. So that isn't going to make any noise or cause any issues. So I'll just leave that alone. All the tubes are in it, which is nice to see. Nobody's taken any tubes out. So somebody shielded this tube. This is a glass version, a 12SA7, but the glass version, and then there's a shield on top of it. Now, in order for this to be correct, there's going to have to be something that comes up from the base on the side of the tube here. And there it is. So that's the little pin. Pin 1 is the pin that grounds out the shield, or connects the shield to the ground here. So in a metal tube, this is internally connected to the metal case. So whether this is factory or not, at this point, I don't know. But this can be replaced with a metal tube if so desired. So you don't need to use a glass tube with a metal shield. Factory electrolytic is still there. It looks like it's in relatively nice condition. Nothing too incredibly major wrong with the top side here. It's all complete at any rate. Let's see what we're up against on the underside. And lots of original components there. So what I'll do is I'll steady the camera up and get this nice and squared up in the shot, and we'll take a closer look at the underside. Here's a closer look at the bottom portion of the radio receiver. And for those of you that are used to working on printed circuit boards, this will look like a rat's nest to you. Yeah, I admit, it does look a little bit like a rat's nest, but this is the way they used to put things together way back when. This is known as point-to-point wiring. It might not look pretty, but it is functional. And when I go through here and change the components out, chances are it'll look a little bit better. You're kind of limited to the way that you can clean something like this up just because of where they've put the terminal tie strips and how it's wired and things. But the newer components are much smaller, so chances are it'll look just a little bit better than this when it's all done. So in lower frequency applications, this type of lead length and things like that isn't such a big deal. When you start to deal with high frequency applications and things like that, lead length like this really does start to play a role in the performance of whatever the piece of equipment is. Anyways, I'll talk a little bit more about that kind of stuff when we encounter that in a higher frequency piece of equipment. Over in this corner here, we can see that there are 3 capacitors that have been replaced. Now, there's nothing wrong with these capacitors. The way they've been put into this circuit here is a problem. So what's happened is the person before me, technician or just whoever hobbyist that's been working on this, what they've done is they've left the original capacitor in circuit and they've just put the new capacitor across the old one. You can't do that just because the original capacitor is still attached. So usually, and much of the time, not all the time, but much of the time, these capacitors will fail in a short circuit condition. So basically, you put a brand new capacitor across one that may end up shorting out. When these original capacitors short out, what they do is they damage the rectifier tube. There's a bonding wire inside the tube from the cathode to the lead out pin. It's a really thin little wire. And what happens is an overcurrent situation will blow that bonding wire off inside the vacuum tube. And then not only are you replacing capacitors now, but now you're starting to replace vacuum tubes. Contrary to popular belief, many of these old radios with their original tubes will work just fine. Tubes are incredibly resilient. There's been many radio receivers I've worked on where all the tubes are nice and strong. Most of the problems in radio receivers like this come in these things right here and that electrolytic capacitor. So this capacitor here is known as a paper and foil style capacitor, not to be confused with paper in oil. So paper and foil, and inside this capacitor is rolled up paper and foil in order to make the capacitance. Now the paper inside is decaying, it's going acidic, and the capacitor itself is becoming electrically leaky. So what ends up happening in here is the actual capacitor itself is turning into a resistor. When the capacitor turns into a resistor, it starts to pass DC and it will load other portions of the circuit. If any of these capacitors are in coupling situations or if they're in a bypass situation, again, they'll end up shorting, they'll end up boiling. When they boil, they start to look like this. And they'll pull the high voltage to ground. So they'll pull the B plus to ground, and then again, it damages the rectifier, or if you have a fuse, sometimes it'll take the fuse out or cause problems in other portions of the radio. So all of these capacitors have to go. Whenever you see a wax capacitor, there's no question. You can't leave it in there. It has to go. So these will all be leaky. And when I say leaky, I don't mean physically, I mean electrically leaky. Every one of these will get replaced. Now these capacitors down here, these domino style capacitors, mica style capacitors, most of the time are okay. They can be left in circuit. Now depending on where these mica capacitors are, some of them have been hand picked for these radios to make the dial track correctly. So if you replace these mica capacitors in communications receivers and things like that, if they were hand-picked, you'll have a really hard time making the dial pointer align up, even after an alignment. So if you can leave the mica capacitors in, it's definitely a good thing to do. Again, very rarely do these fail. Now they do, just like every component. Some of them will fail. They get crackly, or if moisture's got inside them or something like that, they will fail. But most of the time they're okay. So chances are this will be okay. This one will be okay. This one will be okay. And here's a ceramic capacitor. This one will be okay over here as well. And there may be some hiding elsewhere. So something to keep in mind, if you don't have to replace the domino style ones, don't do it. Now some of the very early radios, they disguised these capacitors and there's paper inside them. So most of these capacitors that you see like this will be a mica style capacitor though. Again, there's so many different things that different manufacturers have done over the years. But I guess you could say the majority of radio receivers, these will be a mica capacitor. These resistors here are known as roundies. You'll see that this one here has got kind of a chocolatey brown coating on it, and it's not very smooth like this resistor over here. This resistor is known as an Allen Bradley style resistor, and it has squared off ends on it. Now these are very resistant to moisture. Now moisture can still get in there depending on the climate it's been left in, but they're resistant. These here are very susceptible, these roundies here are very susceptible to moisture ingression, and what ends up happening if these have been in a damp attic or basement or something for years and years and years is just because of the moisture being around and these things been sitting in maybe an atmosphere that hasn't been controlled, these will drift in value. Now these resistors both are carbon composition resistors. They're not carbon film, they're not metal film, they're not metal oxide, they're not anything like that. These are carbon composition. So they have a plug in the center of them, a carbon plug in here. And they're very close to the same type of build inside. The only difference is that this one is sealed quite a bit better than this one. You'll notice that this one here doesn't have a fourth band. The lack of the fourth band means that this is 20% tolerance. So this is a really wide tolerance range on this one, where this one here is a silver band, which means that it needs to be within 10% of its rating. Now, whenever I go through a radio like this one looks like it's been kept very well. That doesn't mean that these resistors should not be tested. So I'll go through and test all of these. If they're close to value, this is a roundie, this is a roundie here, and it doesn't look like there is many of them. Most of them are the newer Allen Bradley style. You can see them, they're all over the place here. But I'll test them, and if they're close, I'll leave them in. If they're way off value, of course, I'll replace them. Now, when I encounter a radio like this that has all roundies in it, like this, and the reason I say roundies is because the ends are rounded off. So if you look closely at these with a magnifying glass, they kind of look a little bit like the shape of a hot dog wiener. All right, they're rounded, where these are squared off. The Allen Bradley ones are squared. Very, very sharp corner on them. So if I go through a radio and I find lots of these roundy style resistors in them, I'll test maybe 5 of them. And if all 5 of them are way off, all of them will get replaced. I'll just stop at that point and I'll just replace all of them with a newer style resistor. If I test 5 of them and they're all spot on, usually you can just leave them all in. Now the thing is with all resistors in a radio like this, they should all be tested. And the nice thing about testing resistors in a radio receiver like this is vacuum tube circuits are high impedance circuits. So much of the time when you test these resistors, they can be left in circuit and they'll test just fine. A lot of the time they'll go to a portion of the circuit that looks like an open circuit unless the tube is on. And this applies to vacuum tube guitar amps and things like that as well. So a lot of the times it's okay to test them in circuit. What I do is I test them in circuit. If it's wildly off, sometimes I'll open one leg and test it again. And if it's, some other portion of the circuit is dragging down the meter or something like that, you can tell at that point. But again, the majority of the time, these older radios are very easy to work on. Just test each one in circuit just like this. And a lot of the times, you'll get good results. The line cord itself looks to be like it has been changed. There is no line cord restraint on this. There is some high heat shielded tubing here, but again, no restraint. It just kind of bows and comes out here. So this will get replaced with an appropriate line cord, and a restraint will be added inside here. So quite a bit of work to do on the bottom portion of the chassis here. So what I'm going to do is I'm going to get to work on that. I'm going to start replacing out all these components. And when I have everything out, I'll test a couple components with you and I'll show you exactly their failure points. And then we'll move on to an alignment and listen to the radio receiver, see how well the thing receives after it's been rebuilt. All the new components have been installed. You can see I've installed the new capacitors on a terminal tie strip over here. The old capacitor is completely disconnected. All the waxies have been replaced. The domino style capacitors, these micas, have been tested. Everything is fine. Very rarely do these ceramic capacitors here ever fail. So I'll just test that one by turning the unit on itself. I replaced only 2 resistors, and the reason I replaced them is they had moved a little bit. It was still okay. I could have left them in there, but since I have the chassis out right now, I may as well just replace them just to be safe. So I put a new 47 ohm resistor there and a new 18 ohm resistor here. This one here was really discolored. It had gotten quite hot, and this one is in series with the filaments. So new line cord put in. This is a cloth line cord. It is a reproduction cloth line cord. So what's in the middle is a standard line cord, and it has a reproduction look to it. So it's almost like they've put, there's a trick to doing this. A lot of people, they cut shoelaces apart and they'll put a shoelace over just a standard line cord, and that seems to work. It looks very close too, but this is done and molded and everything, and the plug itself is polarized, which is a real benefit to this radio. A fuse has been installed. The switch has been rewired. If we take a look at the schematic here, I'll just grab that. If we take a look at the schematic here, in most of these All-American 5 style radios, you'll see that in one of the lines they put a switch, but that goes right to the negative side of the capacitor. So technically they're putting the switch in the common side. So you can see here, it says 105 to 125 volts AC or DC, right? There's no transformer in here, so this can be operated on DC. If this was operated on DC, this would be the negative side with the switch in it, and the positive side would run down to here, or the unit wouldn't work. It would be hooked up backwards, right? Because you have a diode here, allowing current flow only one way. So one of the modifications to make these radio receivers safer is to make the neutral line solid and put the switch in the hot side. And that has been done with an additional fuse has been added in here as well. So there's a fuse right here that you can see. This is an absolute value fuse. So if something really goes wrong with the radio receiver, even beyond the cathode bonding wire, going away, this here will very quickly open up. So this is protection. So the hot lead goes directly to the fuse first, and then everything else in the radio. Very first thing in line is always the fuse. So absolute value fuse right there. And, just the standard stuff that happens with an All-American 5 radio, move wires around, make sure that things are out of the way. These two tuning adjustments here, one is for the oscillator, one is for the antenna. They need to have access from the bottom of the radio. There's two little caps that you can remove to tune this if you want to fine-tune everything. Say you tune this on the bench and it doesn't align up very well, and when it's inside the radio, sometimes things change when you put the antenna on the back and things like that. So they allow you to actually go in through the bottom of the Bakelite case and go into here and tune these. So it's a good idea to always push these out of the way and give yourself some room. And of course, these here should be floating in free air. They shouldn't be pressed up against anything. So these are standing up. And you'll notice that this runs right to the grid. You have the converter tube right over here, and then runs right out to here. And then there's an adjustment right down in there that I can very easily get to if I need to do any adjustments inside the case itself. Again, you just pop the two little caps off the bottom of the Bakelite cabinet, and you can get to those adjustments right there. And that's pretty much it. So the cord restraint here is just a bunch of zip ties, and they've been glued onto the line cord. And this is a new rubber grommet that I've put in here, and the rubber grommet was actually pretty large, so it actually allowed me to put a piece of number 14 wire around the rubber grommet and give it a bit of tension, so it tensions on the line cord just a little bit nicer. It's not super tight, it can still move around, but it holds everything in. And there was two screw holes here, actually two punched holes in the chassis that weren't doing anything, they're just there. So I used those to hold the copper wire nice and tight and to hold the grommet in place, so that worked very well. So lots of safety things have been added to these radios. All of these older radios need these safety precautions added nowadays. The polarized line cord and, keeping the chassis of the radio as close to the neutral side is really an important step to do. Whenever you're taking one of these old All-American 5 transformerless sets into any type of a restoration, you want to make sure that you definitely want to make sure that that is something that is addressed, because way back in the day, line cords weren't polarized. Both of the sides look just like this. You plug it into the wall like this, or you could plug it into the wall like this, giving you a 50-50 chance of bringing the chassis very close to the hot side. And there's other things as well I've talked about in many of my other videos restoring All-American 5 radios. So that's done. I've put all the tubes back in. I haven't cleaned anything up. So what I'm going to do is just flip the chassis over, put the antenna on the back side, and let's see if it works, with just nothing done to it. It's just all I've done is just restored it. No tuning, no oscillator adjustment, no IF adjustment, no nothing. All I've done is just replace the caps and a few resistors here. Let's see what happens with the original tubes too. It would be kind of interesting. I have the internal antenna reconnected to the radio receiver, and it needs to be connected to do any type of alignment or to verify the performance of the radio receiver, because this antenna is part of the circuitry inside this radio receiver. So to give you an example, the main tuning capacitor here has two sections in it. This portion of the capacitor tunes the oscillator. This portion of the capacitor tunes the antenna. So as you are tuning through the band, you can see this portion of the capacitor is ganged to this portion right here. So as I'm tuning this, you can see they're both moving at the same time. Well, this portion of the capacitor is continually peaking up the sensitivity of the antenna section here to keep it as sensitive as possible as you're tuning through the entire band. While that's happening, this is continually tuning the oscillator over here as well. So something to keep in mind, if you find one of these radios and it's in stunning condition and it's missing the back, well, it might look really good, but unless the back is included, unless this antenna is included, you're going to have a really tough time making this radio perform the way it's supposed to. You'll notice that I've replaced that wax capacitor that attaches to the external antenna connection with a safety capacitor. It's another very important thing to do whenever there's any connection that leads to the outside world. If there is a wax capacitor in there to begin with, you want to replace that with a safety capacitor. Now, this is an All-American 5 style radio receiver, and there's also the All-American style 6 radio receivers. They are a transformerless set. So whenever you're working on something like this, it's very important to have the line cord attached to an isolation transformer or variac supply with an isolation transformer in it. Mine is all three. It's current limited, it has a variac, and there is an isolation transformer. The isolation transformer isolates the chassis from the main line. So basically it's a one-to-one transformer. I talk about the dangers of not using one of those transformers whenever you're working on radio receivers like this in many of my other videos. For example, if this was wired incorrectly or your outlet was wired incorrectly and it had a polarized cord and you plug the cord in, there's a really good chance that the chassis of the radio receiver could be very close to the hot side. Okay, and if that happens, and say you want to attach a piece of test equipment to this, if you attach the common probe of an oscilloscope to the chassis and the chassis is hot, it will blow the probe right off of your oscilloscope. Chances are it'll destroy the probe, possibly your oscilloscope, and it is a danger to you as well. So you have to be very, very careful. So if you're following along, you're doing so at your own risk. If you're not familiar with working on All-American 5 or All-American 6 style receivers, I strongly suggest you do quite a bit of research before you endeavor into a project like this. So just be careful. I have my isolation transformer and current limited variac supply switched on, so all I have to do is turn on the radio receiver and let's see if this thing comes to life. So we'll turn one of the lights off here first. And turn it on. That's a good sign. That's normal. When you first turn the radio on these radio receivers, the light will get bright for a moment, dim out, and then when the radio starts to draw current and the rectifier warms up, the light bulb will get brighter slowly as it comes into emission. And you can see that it's doing that right now. I hear a little bit of hum in the speaker. That is a good sign. These All-American 5 and All-American 6 style radio receivers will always have just a little bit of hum in the speaker. It's just the way they are. Half-wave rectification, just the way that they're built. So there are some exceptions like that FADA radio that it seems like there was no expense spared when they put that thing together. So they actually have a filter reactor in there and that really cleans it up. So very little hum in that FADA radio. And I think that's one of the reasons that they're so incredibly sought after. They're just a really good design. But this is very standard for most All-American 5 and All-American 6, even with the standard little 7-pin miniature tubes. It's the same thing. There's always just a tad of hum in the speaker, and I can hear that. So I'll turn up the radio receiver. And that is a really good sign. Just a little bit of volume, lots of static. That means that it's trying to receive. Yes, it's working quite well.
Project managers. Representative, you can call.
Okay, so there's lots of sensitivity in this radio receiver, so it's definitely working very well. So an IF tune-up, so basically somebody's probably been in here throughout time and probably screwdrivered these little adjustments in the top of the IF transformers here, so the IF could probably use a touch-up. And then of course there's an alignment for this capacitor here, which is the antenna tuning capacitor, and there's also an alignment for the oscillator to make the dial track correctly with the needle. And those are the adjustments that need to be made yet in order to complete the restoration of this radio receiver. So before I start with the alignment, what I'm going to do is I'm going to quickly clean up the chassis, clean everything off, and get that all done. And at that point, we'll perform an IF alignment. I'm ready to perform the IF alignment on this radio receiver, and that requires the adjustment of these 4 what look to be screws in the top of these IF transformers. Now these are variable capacitors, and each one of these has to be adjusted for a peak on the oscilloscope screen. That is out of focus right now, but when we do the adjustment, I'll focus that up. So one thing that needs to be thought of every time this happens, or whenever you're working on a radio receiver, is if you have an adjustment like this, a lot of the times they're really stiff. They don't want to move, right? Because they've just been frozen in place for a long period of time. So it's very tempting to get a regular screwdriver, pop it in there while the radio's on and give it a turn. Well, in some radio receivers, these portions of the capacitors are live. So if you touch that to the outer case, to the IF transformer case, you'll short things out. You have to be very careful. Now, I've measured these, and these are not live in this radio receiver. So I'm okay. I can use this tuning tool, and it'll be absolutely fine. Now, these aren't powdered iron slugs or anything like that. These are just adjustments on the top of variable capacitors. So a lot of the times, a regular screwdriver, if they are not live, is okay to use. Now, that's one thing you have to be very sure of. Now, remember that the chassis of the radio is isolated from the line, usually through a capacitor. Sometimes it isn't, so you need to know that as well. So a lot of the times it isn't just okay to take your digital multimeter probe, touch the ground to here, and then measure for DC across this, because this is isolated sometimes. So this all has to be known before you use a metal screwdriver or anything like that. So this catches a lot of people, and it'll damage the radio if you touch the screw and touch the case of the transformer at the same time. So I have my signal generator running into the tuning section here, right? So this is running into a grid of the 12SA7 over here. And it's isolated by a 0.01 microfarad capacitor, which is fine. It's really not specific at this particular point. You use a 0.1. I think they specify a 0.1. I have a 0.01. Absolutely fine. As long as you get signal in there and you don't overload the receiver, you're absolutely fine. So my signal generator is just running into this right now and feeding a signal into this. The common of my signal generator is attached to the case of the capacitor. So to the case of the capacitor here. Again, this is on an isolation transformer to keep things safe. So what I'll do is I'll turn on my signal generator right now, and I'll move the focus over to the oscilloscope screen, and I'll look for maximum amplitude here. So I'm just looking for the maximum amplitude, and I should be absolutely fine. The signal is really weak. I just have this connected right across the speaker, and that's fine. So I'll go with this one here. If I turn it down too much, you can see I pass it. I can also use the volume control to turn this up just a bit. You can see if I pass it, I need to go back to the peak. Right, there's the peak for that one. And we'll go to the next one. That one's pretty close. Right, there's the peak, and move over to the next one. Oh, lots of gain in that one. So this was way out. So I'll turn this down. So yes, somebody was in here and screwdrivered this. And I'll go over to this one here. And that one's pretty close. Right about there. Now, once you find the peak, it's always good to do this one more time. So start here and move your way across. Do it one more time, and at that point, this is maximum amplitude, or very close to, and the IF alignment is done. The next portion of the alignment is called the dial tracking alignment, or the oscillator alignment. And what we want to do is, I'll just turn this down, we want to make sure that where the needle is pointing is where we're actually listening. So the adjustment point for this is 1650, so that would be right between this mark here and this mark here. So we should have a signal right about here. So what I'll do is I'll turn the volume up again. The signal generator is set to 1650 right now. So let's see where it's actually sitting. It's right off the end. So technically that tone needs to be right there between those two marks. So in order to adjust that, I have to, I'm using these screwdrivers to prop the radio up off the antenna here, I have to adjust this adjustment, this capacitor right here on the top of the variable capacitor. So this one here is what adjusts the oscillator so that the dial tracking is correct. So now I need to just adjust this until I hear that tone and maximum amplitude on the oscilloscope. So I'll just turn this. Until I find it. Oh, there it is. Oh, look at how far off that is. And that would be maximum amplitude. So now, when I move this, that's at 1650. That's 1600 right there. 1650, and that would be 1700 right at the end. And now the dial will track correctly. So when it points to 1000 AM, the dial will point to 1000 AM. Now that that's done, there's one more adjustment to do, and that is the antenna adjustment. Oh, by the way, the signal generator is just clipped to the back here. It's not connected to the antenna in any way, shape, or form. So there's a very light signal coming out of my signal generator, and it's just close to the antenna. The last portion of the alignment is the antenna trimmer adjustment, and that's on the underside here on this capacitor. That's the reason that they have those little caps on the bottom portion of the radio receiver. So you remove the cap and get a tuning tool up in here. So I'll align this here, and then when I put this in the cabinet, chances are I'll align it one more time, just the antenna portion inside the cabinet, just to make sure everything is absolutely peaked up. So right now the signal generator is setting at 1400 AM, which is right over here. So when I tune the needle over here, this will be a good test of the dial tracking as well. We'll see if that lines right up, and I should have a tone at 1400. And then I want to peak that with that trimmer capacitor on the bottom side here for maximum amplitude on the oscilloscope. So I'll move this down. Let's see. Hopefully it's at 1400. There it is. Spot on. So now I need to tune for maximum amplitude. So I need to go through the bottom portion of the radio here. See my tuning screwdriver there coming through. And get that into that capacitor. And wow, look at all that gain. And that's about maximum amplitude right there. So this receiver is going to have a lot of gain compared to before. So it should be interesting to listen to the radio here in just a moment and see how well it performs. So I'll get it back into the case and we'll do that. Just before I put the radio back in the case and we see how well this performs after all of this tuning and this rebuild, I should show you how to set the presets. It's really quite simple. So right in the middle of this tuning knob is a screw, and it's countersunk. It's way down in here. So all you do is you just loosen that off just a little bit. You don't have to take it right out. So you just loosen it off just a little bit. So what you want to do is use an insulated screwdriver and put that in there. What you do is you hold the tuning knob steady and just loosen the screw off just a little bit so that there's still tension on it, but the mechanism is now loose. So say you want to set the first button here to, say, 650. Okay, so you tune this to 650, just like so, and then hold this steady at 650, and then press this button in right down to the bottom. Now that one's set to 650. Say we want to set the second one to 1000, or 1 megahertz. Put it to 1000, hold this steady. Now that one's set. And just like that, and when you're done with all of them, all you do is take your insulated screwdriver and then hold this steady, and then just snug this up. You don't want this too tight. You don't want to risk cracking anything here. So I'll put this over here just to get it out of the way. So I'll press the first one, 650, and the second one, 1000 or 1 megahertz. And just like that, it's just that easy. Very simple to set up. Now that the radio has been electrically restored, let's see how well it receives. Let's see how well it pulls in some radio stations. So I'll give it some volume. That should be loud enough, and I'll tune through the band.
Number one, both of us said the funding or research below. Lockheed, Zombies in big house. Diminished. People have the funding. And can Husky play Aerosmith? If he takes 33. Good job, Max.
Wow, lots of radio stations in there. So this should be a lot of fun to listen to some late night DX or distant stations on. I really enjoy doing that with these older radio receivers, just tuning through the band and seeing how many distant stations this will receive late in the evening. It's a lot of fun. So all in all, project successful. This radio works top notch and I'm very happy with it. And it's another radio that has been saved and returned to its former glory. Thanks for stopping by the lab today. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. If you want to be notified as soon as I post a new video, don't forget to tap the bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, you're definitely going to want to check out my ongoing electronics course on Patreon. I've also released many of my personal inventions and designs up there as well. Definitely check it out. I'll put the link just under the video's description under the Show More tab. So if you click on the Show More tab, it'll expose the link. And I'll also pin the link at the top of the comments section. So click on the link and it'll take you right there and you can check it out. All right, until next time, take care. Bye for now.